Hi and welcome to E-ZTutoring. Today we're going to cover how to determine the end behavior, whether a function is odd or even, and the number of zeros. So let's start off with our first function that looks like so. So let's first start off with the end behavior. The end behavior, all you need to do is what does it do towards the left of the graph. So as it goes left, you can see it continues to rise that way, which means that it will rise towards the left. And when we go towards the right side, we see it goes this way forever, and it falls to the right. So rise left, falls right. That's it. Our end behavior is done. Now we need to find out, is this function odd or even? Odd or even. Now, if your function has symmetry about the y-axis, then it is going to be even. Now that means if you just simply flip it over the y-axis and you get the same exact image, your function is even. Now, for odd, if your function has symmetry about the y-axis and x-axis, then it will be even. What that means is if you take your function and you flip it about the y-axis, so we flip this about the y-axis like so, we'll get this image. Now clearly, this image does not look like that image. But now if we take it again and we flip it about the x-axis, now we get this image. And this image looks exactly like what was already there. So since we flipped it about the y-axis and x-axis and we got the same thing, therefore this function is an odd function. And that's how you can tell just by looking at the graph. Now in some cases you will do y-axis symmetry and y and x-axis symmetry, and you still won't get anything to match up. In that case, it would be neither odd nor even. Now the last thing we need to figure out is the number of zeros. So for this we need to look at the original function, and you need to disregard the mess that I've made here. So in the original function, we're looking at this. We want to think, where do you plug in a number for x and get a y value of 0? That's what it means to have zeros on your graph. So we look over here, and over here we have a y value of 0. And we go, and over here we have another y value of 0, and we have the last one over here. So pretty much it's wherever your graph crosses the x-axis, that's where you have your zeros. Now, you will, of course, have to look at the multiplicities. If you guys remember multiplicities, it will just bounce right off the x-axis if it has a multiplicity of an even number. And if it crosses through, it will have the multiplicity of an odd number. If it crosses straight through, it has multiplicity 1. If it does kind of like this little thing and has kind of that cubic look to it, then it will have multiplicity 3. In this case, they're all multiplicity 1, and we have 3 spots where it crosses, therefore we have 3 zeros. All right, let's go ahead and do one more. So let's suppose that we have something that looks like that. That is our function. So of course we are going to start off with end behavior first. We want to find the end behavior. So we look towards the right of this function, and towards the right we can see, of course, it just rises on forever. So it rises to the right, and towards the left we can see that it just falls. So it falls left and rises to the right. Now we want to know, is this an odd or an even function? Well, remember, like I said, if you flip this across the y-axis and you get the same image, then it's even. So if we actually go ahead and flip this about the y-axis, we'll get something that looks like so. Now obviously this does not match with anything that's over here because there was nothing on this side of the graph anyways. So let's go ahead and flip it about the y and x and see what we get. So if we flip it about the y and x, we will get something that looks like this. Now of course there was nothing over here anyway, so it's not matching with another image. Remember over here we flipped it and it just traced the original function that was on this side. That is not happening in this case, neither for y-axis symmetry nor x and y. So therefore this one is neither. Alright, so now that we figured all that out and we made a big jumbled mess here, now we can find the number of zeros. So for the number of zeros, once again we want to see just where the original function crosses the x-axis, which is right over there. And after we find that, you just need to look at the multiplicity. Now this obviously has a cubic multiplicity. If it were to just cross through the x-axis like that, that would just be multiplicity 1. However, if it crosses through in a cubic shape, it will have multiplicity 3. So in this case, there are actually 3 zeros. Alright, so that is how you determine end behavior, odd and even, and the number of zeros just by looking at a graph. So, hope you guys understood this. If you guys ever need ACT or SAT help, be sure to visit www.e-ztutoring.com. Thank you guys and have a good day.